Hey everyone, in this mini thermodynamics lecture, the topic is properties and equations of state, with the subtopic being phase diagrams. So if you take a quick look, we have a graphical representation laid out for you, and this is a phase diagram. So it's just a representation that shows the physical states of a substance that is under different conditions of temperature and pressure. So a typical phase diagram has pressure here on the y-axis and temperature there on the x-axis. So as we cross the curves on the phase diagram, then a phase change occurs. Also, two states of the substance coexist, and this is an equilibrium on the lines or the curves. So a phase transition is just a transition as we know it from one state of matter to another. So there are three states of matter, right? There are liquids, solids, and gases. So we'll first look at the liquid. So that's a state of matter that consists of loose, very free-moving particles which form the shape that's set by the boundaries of the container that in which the liquid is in. This happens because the motion of the individual particles within a liquid is less restricted than it would be within a solid. So you can notice that some liquids flow readily, where some liquids flow slowly. So a liquid's relative resistance to flow is known as its viscosity. All right, now we move into a solid. So this is a state of matter with more very tightly packed particles which don't change the shape or volume of the container that it's in. But it doesn't mean that the volume of a solid is a constant. Solids can expand or solids can contract, and this happens whenever the temperature changes. So this is why when you look up the density of a solid, it'll say that the temperature at which the value for density is listed. Solids have really strong molecular forces that keep particles in close proximity to each other. And another interesting thing to think about is that all true solids have crystalline structures. So this means that their particles are arranged in a three-dimensional, very orderly pattern. And solids undergo phase changes when they come across energy changes. All right, and then the last one is the gas. So this is a state of matter where particles are spread out with no definite shape and no definite volume. The particles of a gas will take the shape and fill the volume of the container that it's placed in. So in a gas, there are no intermolecular forces holding the particles of a gas together because each particle travels at its own speed in its own direction. The particles of a gas are much often separated by great distances. So the major feature of a phase diagram are the phase boundaries and also the triple point. When I talk about the phase boundaries, I'm talking about the line in red, in green, and in blue. And as you can see, the triple point is marked. So the phase boundaries, or we call them the lines of equilibrium, these are the boundaries that show the conditions under where the two phases of matter can coexist. Two specific phases of matter can coexist, that is, at equilibrium. And then there's the triple point. So the triple point is just this point on the diagram where the lines of equilibrium all intersect, right? So this is the point where all phases of matter, which is the solid, liquid, and gas, they all coexist together there. All right, so the phase diagram for water is useful for learning how to look at these diagrams and to make some sense about them. So along the blue phase boundary, water exists at both a vapor and a liquid. And along the dotted green phase boundary, we see that special behavior of water, where it exists as a solid at low enough temperatures and high enough pressures. And then at the triple point, water in the solid, liquid, and gaseous states all coexist, as previously mentioned. All right, so let's talk about the critical point. So the critical point, so this is the temperature and pressure where the vapor density of the gas and liquid phases of a fluid are equal. All right, so again, this is the temperature and pressure where the vapor density of the gas and liquid phases of some fluid are equal to each other, right? At which point there's no difference between gas and liquid. So then there's this term up above, supercritical fluid. So this is some substance where at a temperature and a pressure it's that above its own thermodynamic critical point that can diffuse through solids like a gas and dissolve materials like a solid.